connected by a MAC label bridges. So LLC provides three type of services. It provides the services to its user through, it provides services to the upper layer protocols and through this service access points, right? Three forms of services are there: connection oriented service, acknowledged connectionless, unacknowledged connectionless. So we have seen yesterday what is connection oriented service. It is just like your what you have studied in SDLC. Okay, connection oriented service. So as you know that the connection oriented service could be useful where you have a large data to send and large data to send for a long period of time, so that this connection establishment overhead is just it will not overburden you, right? So this is what but there is a disadvantage also when you have to because if a station has to send only data for a small amount of time, and this connection overhead will be a need to be taken care of, right? I have one notification. So the other service like acknowledged connectionless service, can you give any example of acknowledged connectionless service?
FTP.
FTP, file transfer protocol.
Yes, sir.
Okay. So where in which situations it can be good? See, acknowledged connection means what? Like connectionless service, you know, connectionless service is a datagram style service where there is no prior connection, means there is no link is established between the sender and the receiver prior to exchange of data, right? And data travels connectionless means, so since there is no fixed path, data may take, the packet may take any path from the source to reach to the destination. Obviously it will be based on a shortest distance path or the minimum cost path, but actually during this connectionless service, which is also known as a datagram style, which is also adopted by internet IP protocol, also uses the same service. So what is the advantage and disadvantage of this connectionless service is there is no acknowledgement, right? So there is a reliability issue. So as far as you are using a network which is reliable in the sense you have, there is no chance of losing any data packet. You are very much sure that the data will be delivered surely at the receiver end. There are no chances of packet drop in any condition, whether the router is buffer is full or anything you may think of, right? Because of any reason there will be no error, but it is not like connection less is just opposite, because here there is no burden of connection establishment, so that is the strength. There is no fixed path. Packets can travel from anywhere in the network and reach at the destination, right? So for applications which do not require much reliability, can go for this connectionless approach because of no burden of connection establishment. But at the same time, there is no error and flow control provided. And moreover, there is no guarantee of data to be delivered, right? So this connectionless approach could be good where suppose I am taking the readings of this my room temperature. Okay, so if suppose I sampled at 10:15, okay, and the next sample will be taken at 10:30. So at an interval of 15 minutes, I am sampling my room temperature and sending it to my friend, right? So at the same time, from this sensor data, I am sending it to some other remote location. You can assume that within 15 minutes, will the temperature of the room change? Will there be a much difference in the temperature of the room? No. So for such applications, this connectionless approach is good, right? Because if even one or two packets are dropped, the upcoming packets will update the things, right? जैसे आप शेयर you must have noticed the share market. Okay, so the packets are coming so fast. You see that if you see in the TV also, or if you have observed, if somebody is using in your family, you will see that the color changes very fast. Red, green, like that the color will change of the indices, right? So that shows that how fast the packets are coming. So sometimes the user has to pay the penalty of a slow connection, because if you are having a slow connection and your packets will be delayed and you will be updated later only when already the price has been down or up. Okay, so user may have to pay the penalty for a slow connection also. So unacknowledged connectionless is good, where there is no restriction to have error and flow control. Even the packets are lost, there is no issue. On the other hand, if I say acknowledged connectionless service, so the example is a datagram style for unacknowledged connectionless. There is no acknowledgement and it is used in IP, Internet Protocol. Acknowledged connectionless service is useful where you do not want to have the overhead of connection establishment, but at the same time you like to have an acknowledgement. You like to receive the acknowledgement of the data which is delivered, to make sure that the data is delivered successfully. Like, so some cases where you will be handling with emergency data, right? And if that data is missing, like if that packet is dropped, then you may end up in an issue. So you want that the acknowledgement for that data. So for such application, we go for an acknowledgement connectionless service. UDP is an example. UDP बोल रहा हूँ. There are many FTP you said, right? There are many such examples where you can have a acknowledged connectionless service for emergency data. So there is no overhead of connection establishment. There is no error and flow control because of connectionless approach. Packets can travel anywhere in the network and reach at the destination. But at the same time, there will be an acknowledgement of the data. Can you say the difficulty in this connectionless approach? Huh? See, if I say the difficulty in this connectionless approach, like as I said, the packets can move anywhere in the network, right? There is no fixed path. मान लो आपको रांची जाना है BIT से. You chooses a path. There is a main road. This road you will go by a Kantatoli. That route is fixed. But somebody may take an Baryatu road. Somebody may take a ring road. Okay. So from different paths, people can reach Ranchi. Okay. So the issue, what will be the issue at the receiver end?
Delay.
Delay, yeah, you can say delay in what? Suppose I said that everyone has to reassemble at Frayalal, right? People took different routes and they will reach Frayalal at the same time? No, They will reach parallel at different times depending on the network conditions. Okay, and depending on the other conditions, they will reach at different times, right? So then reassembling of all the segments, of all the fragments basically of a datagram, बेसिकली क्या होता है, अगर आप ऐसा ऐसा कर सकते हो क्या कि आपने एक डेटाग्राम बनाया जिसका साइज आपने मैक्सिमम रख लिया, उसको आप भेज सकते हो क्या? नहीं भेज सकते हो। हम लोग क्या करते हैं, हम लोग उसको छोटा छोटा काटते हैं। ये आपने पढ़ा होगा ना फ्रेमिंग में। A frame is how do you make a frame? There is an upper bound on the maximum, because if you have seen yesterday's lecture also, there was a maximum frame size in FDDI of 4550 bytes. So why there is an upper bound? Because once you talk about an internet, right, which is a collection of heterogeneous networks, each network, suppose I am using Ethernet, okay, this network is Ethernet, then followed by that there is an FDDI, okay, then followed by that there is a some other fiber channel, okay. So like that, if there is a net of different networks, there is a collection of different networks, network characteristics are different, right? So each network has its unique characteristics, has its maximum packet length defined, right? So it is not like that if I have decided that my packet size will be of 10,000 bytes, I will be transferring it to the internet. So no, that is not possible, because you know the reason, you have studied this, that every network has got its maximum packet size limit, and so a packet has to, if a packet size is more than that, the network maximum transmittable unit size, then you have to cut the packet into smaller ones. Okay, you have to divide the maximum packet into smaller packets, right? हम उसको क्या करते हैं, कट करते हैं, and smaller packets are sent. Can you say why the data is to be divided, why the frame is to be divided into smaller frames? You have studied these things. And what could be the problem if you have more number of smaller frames? Huh?
सर मोड नंबर होने से डेटा लॉस का चांस ज्यादा होगा?
नहीं, आपका ओवरहेड बढ़ जाएगा ना, बिकॉज देखो कंट्रोल इंफॉर्मेशन विल रिमेन द सेम नाउ. सपोज suppose I have a single frame, okay, I said this is of 10,000 bytes. So there is always a control information lies na. So if I have to cut this frame into smaller ones, first, second, third, fourth, so this control information will remain same na. 1, then control 2, like that. So once I am doing this control information is going to be common. So if I have multiple frames, okay, if I divide it into n number of frames, then this control information will be repeated in n number of things. So this will increase the overhead. Ultimately, this information is required to see who is the sender, who is the receiver, which protocol you are using, okay, who is the what is the CRC, all those things will be a part of this control information. So if this information will be copied in n number of frames, the overhead will increase, okay. So what we do, depending on the size of the network, depending on the maximum transmittable unit of the network, a packet has to be shortened, okay. We will discuss this, but we cannot have very large number of smaller frames, because if it will lead to an overhead, because there will be more overhead as compared to the frames, right? So once you have done that, I think the reassembly of all the segments. Okay, because the segments are moving in the network from anywhere. So once you are saying there will be no sequencing, okay, the last one will reach first, the first one will reach may reach last because of the network conditions, and then sequencing of the fragments are necessary, then reassembly of all the fragments are necessary, because once otherwise क्या होगा, आपने ये कोई सपोज वॉइस, ये कोई एक मूवी का फ्रेम था, ठीक है, you cut this into smaller frames, okay, and you send this in the internet, जैसे हम लोग अभी मूवी देख रहे हैं यूट्यूब में, ओके, या किसी पे भी आप ऑनलाइन मूवी वॉच कर रहे हो, तो क्या हो रहा है कि पैकेट्स आर कमिंग, स्ट्रीमिंग हो रहा है. So either because of the network is slow or whatever reason some packets may be dropped, in that case all these, suppose if we are using internet, so internet uses connectionless service, so all these packets will take a different route to reach at your device at the destination. So at the destination all the packets needs to be arranged back in the same sequence, वरना क्या होगा, मूवी का स्टार्टिंग यहाँ होना था तो वो स्टार्टिंग वाला पैकेट यहाँ आ जाएगा, ऐसा होगा क्या, साउंड कहीं आना था कहीं पहुंचेगा, राइट. So reassembly is also very important. Okay, so at the receiver end the packet may receive out of order, all the packets needs to be put in order and arranged back in this way. So reassembly is also a tedious task at the receiver end when we talk about this, and it is very quite interesting when you will study that on this connectionless service how the internet protocol achieves reliability, because internet protocol doesn't guarantee anything, okay, but still it provides quality of service. Quality of service means, like, if a particular application demands a higher bandwidth, like a movie real-time traffic, okay, you will be watching a movie in your HD connection, okay, so you require a larger bandwidth, right? So how you will be getting that, okay, how the applications are talking and how you will be allotted a higher bandwidth, right? So this is all we will talk. Okay, so I hope it is clear that the three type of services provided by LLC have specific applications. Okay, so how what is the job of a LLC? I told you that this is the LAN, this is one end system A, this is end system B, this is end system C. So you can see that suppose application X, this is a service access point A, this is A2, A3, these are the higher layer data which want to exploit, higher layers which want to exploit applications which want to exploit the LLC services. Okay, so this requested at A1. Okay, so source address is A1, destination address is C1. Okay, so once this will pass down to LLC, will be passed down to MAC. MAC will put it, because LLC is responsible for data exchange over a MAC controlled link. Okay, this link is controlled by the MAC. Okay, and this is a LAN. Okay, and multiple LANs can also be connected using a MAC layer bridges. Another LAN can be there. Another system can be connected. Okay, so this is the same LAN. A, B, C, 3 users are there. So once this comes to LAN will MAC address will say which station a MAC frame is to be delivered. So once it will be delivered to that particular station, station C, and where after stripping of this MAC address, LLC user will see, LLC address will be seen, and that will say that it is to be delivered at this C1. Okay, so like that this works, that MAC address, because once this LLC data will be passed down to the MAC layer will put its MAC header and trailer, and once then it will pass down to the physical layer, it will move, and this MAC address will determine which particular station it is to be delivered. So LLC is responsible for data transfer over a MAC control links. Okay. So it provides three type of operations. Type 1 operation, type 2 operation, type 3. Already we have discussed. Type 1 operation is unacknowledged connectionless service. Type 2 operation is connection mode similar to your SDLC. Type 3 is acknowledged connectionless service. Right? This is LLC PDU. LLC PDU contains a destination service access point, source service access point, control information, and information. It is a user data from the higher. So what is this? You can see that this is the information frame, just like in SDLC, if you remember, where NS is a transmitter sender sequence number, full final bit, transmitter receive sequence number. Okay, this was a supervisory frame, unnumbered frame, I frame, S frame, U frame. Okay, this says about the mode. This is there were three modes, a balance mode, right? कौन-कौन से mode थे? कुछ याद है? Because this can be a command or it can be a response. Okay, if you remember in SDLC, there can be a command, there can be a response. Okay. Supervisory में RR, RNR, reject, unnumbered में your balance mode, okay, sub में, okay, DM, FRMR, all those things. It is sent for an individual or a group. DSAP value, when you are sending to a group of users, okay, it will be a group, otherwise an individual station. DSAP value, CR, SSAP value. C stands for command, and when C is 1, it is a response. So what are the frames which are used in this unnumbered UI, unnumbered information? Okay. XID is exchange ID. Okay. The two users can exchange. Type of operation supported by the user and window size, right? To exchange information about the type of operation and window size, this XID frame is used. Test is basically used to find out any like performing a loop check. If there is any issue in the loop, okay, one test signal is launched and it is found that from where it is reached. So that is a test command to check whether the connectivity is proper or not. So XID is also command and response type of operation and window size. UI, it is a command, exchange user data. Okay. Loopback test. Acknowledged connectionless service में unnumbered frames. Acknowledged AC is acknowledged exchange user information, connectionless information. acknowledged connectionless information. Okay, exchange user information. Connection mode आपने देखा ही था, सब में भेजते हैं HDLC में. तो and if it doesn't receive any information, it's once again timed out and sent sub में. Unnumber acknowledgement, disconnect to disconnect the request. Okay, connection, unnumbered acknowledgement, link setup and disconnect. And this is the data transfer information frame, NS, NR, acknowledgement, when both the sides the data exchange is going on. And this is about a busy condition. Information frame, this is NR, NS, NR, RNR, receiver not ready. So it has rejected, right? Receiver ready. RNR, receiver not ready. So DM is basically disconnected mode. FRMR reports receipt of unacceptable frames. Frame reject. It is called frame reject. It reports receipt of unacceptable frames. This is about LLC. Any doubt is there? Okay. The next is Ethernet. So what is Ethernet? Ethernet we all are using. It is IEEE 802.3 Ethernet. Okay. How do we define the Ethernet specifications? Data rate in Mbps, we write like this, 10 base 5. Okay. So what does that mean? Okay. It is said that data rate in Mbps, signaling technique, and 5 is the maximum length of cable in 100 of meters. So 10 base 5 means 10 Mbps baseband Ethernet, baseband signaling, and the cable length is 500 meters. Okay, so the Ethernet specifications are like this. So we have a standard Ethernet, switched Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit of Ethernet. Okay. So initially we will talk about standard Ethernet. Okay, then we will see how the evolution of Ethernet happened. Okay, from the standard Ethernet. So at 10 Mbps, which is also known as 10 Mbps, or it is also known as standard Ethernet. So we have 4 physical configurations of this: 10 base 5, 10 base 2, 10 base T. T stands for twisted pair. F stands for optical fiber. So this 10 base 5 okay, this 10 base 5 is also known as thicknet. Thicknet, or because it provides a data rate of 10 Mbps, baseband signaling is used, the cable length is 500 meters. Okay, it uses bus topology, and it uses a 50 ohm coaxial cable. Okay, 50 ohm coaxial cable, and Ethernet uses a, so you know that, and this cable 50 ohm coaxial cable which is used, it is very thick. in nature. Okay, so that is why it is called as a thick net. Okay, and because the cable is thick and cable cost is higher, so that is why in this case this configuration 10 base 5, the cable cost is higher. It uses bus topology. It can travel up to, the signal can travel up to 500 meters. Okay, the maximum length of the cable is 500 meters. Okay, not having this. Yeah, so you can see this 10 base 5. It uses a coaxial cable of 50 ohm. It uses a baseband signaling technique, that is basically the Manchester encoding scheme. Okay, the topology is bus. Maximum segment length is 500 meters and cable diameter is 10 mm. Cable diameter. So in this case, so you can see the cable dia is 10 mm. So it is very difficult to band, and if you have to install a new station on this, it is quite difficult, right? Because it uses bus topology. The stations are connected to through the taps, the a drop line. Then a station is to be interfaced onto the bus through the taps, right? So this thick net, because of this cable dia, this is a costly affair as compared to this 10 base 2, which is also known as thin net and cheaper net, because it is only 5 mm. It is also uses the 50 ohm coaxial cable, so it is very cheap and it can easily be bent. New station can be put, but the maximum segment length is 175 meters. While this was 500 meters, it is 175 meters. It also uses bus topology. Okay. And maximum number of nodes that can be connected is 30. Here it is 100. Now the next two, 10 base T and 10 base F, they do not follow the same notation what I said, that this says about the maximum length of the cable in 100 of meters. T and F doesn't follow the same notations, but T stands for twisted pair, F stands for optical fiber. So it uses UTP. Okay, it also uses baseband Manchester, same technique. UTP. The topology is star instead of bus. Maximum segment length is 100 meters. So this is also a cheap kind of thing, because twisted pair, unshielded twisted pair are used. Star topology. Okay, and dia is 0.4 to 0.6 mm. Okay. And this uses Manchester on off, or you can say it uses an intensity modulation, that is presence of a pulse will be marked as 1 and absence of a pulse will be marked as 0. Okay, So it uses intensity modulation. It is optical fiber. It uses optical fiber, and it also uses star topology. It is 62.5 micrometer. Okay, it is also a costly affair, and you can connect. You can go up to 500 meters. Sorry. Maximum segment length is 500 meters. The dia is of 62.5 or 12.5 micrometer. Right. So a comparison among all these type can be asked. Okay. Which topology they use, why they are called thick net, why they are called cheaper net. Okay. So you can see that it uses twisted pair. It is a star topology. This is also a star topology. So the MAC frame for this standard Ethernet is this. There is a preamble, a 7-octet pattern of alternating ones and zeros ending with 0. Okay, this is just for synchronization between the transmitter and the receiver. SFD is start frame delimiter. Okay, just for synchronization, just to say that the next bit is the frame bit. Okay, DA is the destination address of 6 bytes, source address is of 6 bytes, the length of the frame is of 2 bytes, LLC data, it should be greater than 0. Padding to make this frame, okay, I will come to this framing, FCS of 4 bits. So what is an overhead? If you count, overhead is of 7. ये तो synchronization के लिए हो गया. Overhead is basically, other than the data, it is 6 plus 6, 12 plus 2, 14 plus 4, 18. Okay. So the total frame length is 64 bytes. Maximum frame length is 64 bytes. Okay. So 18 bytes are used for the minimum. Sorry, the minimum length is 64 bytes. Okay. So out of that, 18 bytes are used here for overhead, destination address, source address, length, FCS. Okay, 6 plus 6, 12 plus 2, 14 plus 4, 18. So out of that 64, the minimum data that should be of 46 bytes. So if a station is sending a data which is less than 46 bytes, a padding is done to make this minimum, to complete this minimum frame size limit of 46 bytes, right? And the maximum frame size is 1518 bytes. So maximum data can be of 1500 bytes. Okay, maximum size is 1500 bytes. इसमें से 18 बाइट का क्या है, ओवरहेड है. Minimum frame length is restricted to 64 byte and maximum frame length is this. It uses CSMA-CD as a MAC protocol. Okay, where the frame length is greater than the propagation time. This is what the property is used, so that the once the station launches its frame, it will be heard by all other stations present in the network and collision can be detected. The station has to transmit and keep sensing the medium for any possible collision. FCS is 32-bit field to detect error in the frame. This addressing, okay, आप बताओ, आप इथरनेट केबल यूज करते हो, आप बताओ एड्रेस कितने बिट का होता है? How the Ethernet address is written? The Ethernet address can be written separated by these columns, okay, in the hex format or in the bit format separated by columns. Okay, so it supports three type of addresses: unicast, multicast, broadcast. Unicast means you will be sending a mail to one of your friends. Okay, unicast. Multicast, you will be sending a frame to your ECE group. Okay, so that is multicast. Broadcast means you will be sending it to all the stations present on the network. So how does it changes? Okay, so suppose this is 48, so I have written it 0100 1000. So this D0 bit, if this bit is 0, it is a unicast address, and if this bit is 1, it is a multicast address. Okay, so how it is differentiate? How does it differentiate between a unicast station, unicast or a multicast station? By this bit, D0 bit of this first byte. Okay, so this is what unicast 0, presence of 1 means it is a multicast address. And when I am saying broadcast, all the 48 bits are should be high. Okay, so that it will be a broadcasting. All the 48 bits will be high, so it will be referred to as a broadcast address. So it's of 6 bytes, right? So slot time. So as I told you that the frame length should be higher than the propagation time. Okay, so that once the frame is launched in the network, the first bit of the frame reaches to the all other station. So this also dictates what should be the maximum length of the cable. Okay, so how will it be defined? Because we know the slot time. We define a slot time, that is the round trip propagation delay of the network. So slot time is defined as 2 into TP plus amount of time required to send a jam signal. So slot time basically determines the maximum length of a network. And it is defined in bits. Can you say अगर slot time छोटा होगा या बड़ा होगा उससे क्या फर्क पड़ सकता है? See, there can be two conditions. One is under heavy load conditions, one is under light load conditions. So if you choose a slot time, okay, which is much higher in heavy load conditions, what will happen? The stations has to wait for a longer period of time. Okay, because it will take, ideally the slot time should be small, because what does the slot time means? That the moment the station has transmitted, okay, it has reached to the farthest end of the network. Okay, so okay, we will discuss this slot time in the next class. Okay, thank you.
Thank you, sir.